Okay, so this is class example number 2 from chapter 4, the trig stuff. And we want to find the different trig ratios for a specific reference angle, 2 pi over 3. Since there aren't degrees written next to it, and especially because there's a pi involved, you can pretty much assume that that's going to be in radians instead. Oops, sorry about that. So it's in radians. Let's see, do I still have this pasted here? Yeah. All right. And these were the definitions for sine, cosine, and tangent based on any circle that you have, and cosecant, secant, cotangent. So let's figure out 2 pi over 3. If I draw a circle here. So remember, there are 2 pi radians in a circle. So half a circle is pi radians. And if you go halfway around, you get the pi. So 2 pi over 3, if I cut this into thirds, there's pi over 3, there's 2 pi over 3. And thirds, normally I think in degrees, not so much in radians. So if I cut 180 degrees into thirds, then this is 60, 60, and 60. So really my angle here, 2 pi over 3 radians, is the same as 120 degrees. So let me do this. I'll clean up the picture a little bit. So we've got this right here. This angle is 2 pi over 3 radians. And I'll put in parentheses 120 degrees. And what we need to do is figure out these trig ratios. So I know my theta, but I need a y, an r, and an x to be able to fill in all of these guys. So the nice thing about this problem, you can do this without a calculator. This angle right here is 60 degrees or pi over 3 radians. So I tend to work in degrees, but 60 or pi over 3. So what I can do is I can make a 30, 60, 90 triangle right here. So 60 here, 90 here, 30 here. And remember, there are specific ratios that go with a 30, 60, 90. The smallest side's opposite the smallest angle, so this is x. Medium side opposite the medium angle, this is x root 3. And the largest side opposite the largest angle, 2x. Although, let me use a's instead of x's, since x gets used for a coordinate instead. Okay. Well, to be honest, you don't have to pick general a root 3, 2a. You could just make up whatever values you want for a. So to simplify it, I'm going to go 1, root 3, and 2. So then this coordinate here, this xy coordinate, xy, is going to be -1 since I'm going backwards 1 unit, and then up root 3, so it's root 3. And just remember, radius here is 2 because that's what this happened to be right there. Some students, when you're using trig here, they put a -1 there just because it goes to the left. If it were going down, then that would be a negative root 3 instead of going up. So it depends on if you want to do that or not. I'm not going to be picky about it. Okay, so we've got an x, we've got a y, and we've got an r. So now I can just fill in all these things. So y is -1, or sorry, root 3, and r is 2. So sine of 2 pi over 3. Actually, let me write this out. So sine of 2 pi over 3 is going to be y over r, root 3 over 2. And cos theta, or cos 2 pi over 3 is going to be x over r, so -1 over 2. And tan theta, tan 2 pi over 3, is y over x. Y over x is root 3 over -1, or negative root 3. Remember, tan theta can also be interpreted as the slope of that line. Well, it's down root 3 and over 1, so negative root 3 over 1. And then all these guys here are the reciprocals of their partners, so cosecant theta is going to be 2 over root 3. Sorry, theta is 2 pi over 3. Secant 2 pi over 3 is the reciprocal of cosine 2 pi over 3, so it's going to be -2 over 1, or -2. And then cotangent 2 pi over 3 is going to be -1 over root 3. So there are all our 6 trig values for that reference angle. So let's keep going. Let's do the specific one, tan of 7 pi over 6. Okay, so 7 pi over 6, remember, getting to here, That's pi radians. So I gotta go, that's 6 over 6 pi. So I need another pi over 6 right here. So this angle right here, pi over 6 radians. Well, if I cut pi into sixths, that's like cutting 180 degrees into sixths. So that's 30 degrees each. So this extra angle right here is 30 degrees if you like thinking in terms of 30, 60, 90. So just like we did in the previous problem, I can picture here a 30, 60, 90 triangle. So I'm going to pick some convenient values, 1, root 3, 2. And since it's really backwards 3 units, I'm going to say -3. Since it's down 1, I'm going to write -1. So this coordinate right here would be -√3, -1, and the radius is 2. So this is my xy equals that, and r equals 2. So, and you can kind of picture that there's this like kind of circle going around with radius 2 here. So I need tan of 7 pi over 6. So tan of 7 pi over 6, that's my y over x. So y is -1, and x is -√3. So this is 1 over √3. And remember, tan you can interpret as the slope of that radius, right? So the slope of this radius is the rise over the run, 1 over √3. And that's what we got. Okay, let's see how we're doing on time. Okay, I'm going to do one more here. So example 4, let's look at tan theta equaling -3 over 4 first, and then we'll deal with this next. So first this. So we know tan theta, the definition of it is y over x. So in this case, that's, I could think of the y as -3 over 4, or I could think of the y as positive and the x is negative, so 3 over -4. So that's what we have. So in one case, I could plot a point that says y is -3, so -1, 2, -3, and x is 1, 2, 3, 4. So that's this one. And that would put me right here at 4, -3. And in this case, I've got 3 over -4. So the x is -4, -1, 2, 3, 4. And the y is 1, 2, 3, right there. Whoops, a little bit higher. Right there. And so this coordinate is going to be, let's see, -4, +3. So I get these mirror images of each other, right? They're reflected about the origin. And then I've got this other thing here. Sine theta has to be positive. Oh, by the way, this value right here, you can kind of picture a circle going around. This radius, if I figured out how long it was, you'd end up doing Pythag here. 3 squared plus 4 squared equals r squared. Well, that's part of a 3, 4, 5 triangle. So we also know r equals 5. So what I need now to think about is sine theta is positive. Well, sine theta is y over r. And so I need y over r to be positive. Radii are always positive, right? You can't draw a circle with a negative radius. So that means that y also has to be positive. So it turns out that this one down here where the y is negative, we're not going to look at that part down here. That doesn't matter. We're only going to look at this part up here. Ooh. That part. Okay, so I need cosine theta. By the way, that means this is my theta right here. Or it could also be something like 360 plus that would be my theta. But we'll get back to that later. Okay, so cosine theta is x over r. So in this case, x is -4 and r is 5. And cosecant theta is r over y. And so that ends up being, what, 5 over 3. Okay, and then there are your two answers. So, hope that helps.